Okay, so this last one, yeah, it's a little tricky. What's going on here is we have these rational exponents appearing more than once. If you look at the previous examples, we only had one rational exponent. So the way we're going to do this, the way they show you in the video is to use this thing called substitution. And so the first thing I'm going to do, though, is I'm going to set this thing equal to 0 by adding 12 to both sides. So I'm going to have y to the power of 2/3 minus 7y to the power of 1/3, and then plus 12 equals 0. So, this is kind of a chance for us to introduce to you this concept of substitution in solving a problem like this. Really, you don't have to use substitution, but like I said, it's kind of to show you this way of doing things. And so what you would do is you would say, okay, you know what? Let u equal the y to the power of 1/3. And then if you think about it, if you were to square both sides, you'd end up with u squared being equal to, remember, power to a power you multiply, that'd be y to the power of 2/3. So I can substitute those in for these values right here, right? So y to the 1/3 that I have written in red is equivalent to u, and y to the power of 2/3 is equivalent to u squared. So I'm going to go ahead and put that in here. And once you get to this point, hopefully it looks familiar. It's a trinomial, and we can factor it. And so I like to use this thing called the A&M method. Whenever the leading coefficient is 1, you can use this method called the A&M method. And basically what you're trying to do is figure out what will multiply to give you 12, but add to give you -7. So a combination of numbers that when they multiply, they're 12, but when they're added together, it's -7. And that's what this kind of factors into, because the u goes in the first spot here and here, because u times u is that u squared. And then the inner and the outer have to add up to that -7u. But then the last two have to multiply to give you the 12. So in this case, it's going to be a -4 and a -3, because if you multiply those, it's 12. And if you multiply the inner and the outer part, you get -3u and -4u, which adds to give you -7u. Okay, so then we go ahead and solve each one of these. So you would get u equals 4 if you were to set that equal to 0 and solve. And here you would get u equals 3, right? But wait a second. We use substitution. What is u actually equal to? Well, if we look back here, you can see that u is actually y to the 1/3. So I'm going to change it back to y to the 1/3 equals 4, and y to the 1/3 equals 3. And then to solve this is actually this shouldn't be too bad. It should be one step. We're going to raise both sides to the power of 3, and that 1/3 times 3 becomes y. Then 4 to the power of 3 is 64. And then right here, we're going to raise both sides to the power of 3. So that will become y equals 3 to the power of 3 is 27. So there we go. There are two answers right there.